have to worry about remembering a calculator, right? Have that calculator ready to go.
Another box.
Y'all are, what class is it now?
Bible. Our teachers in the
Well, you're having a lovely day.
I know. Oh, you were there.
I gave you an extra. Well,
Angelina and Grace got up that box.
there's the box. And that's the last box that's not done. So you have to go to Mr. Rogers if you want more. All right. So if you got the last lesson, this is going to seem simple. But some of the numbers are kind of big. So yes, and you can use a calculator. But when you use a calculator, it doesn't take away from showing me some of the work. And so I'll tell you the work that's expected, but I'm going to show all the work so that you know what I'm doing. All right? So I want to make sure it's clear. So we're going to do something called a series. And when we get series, we get this Greek letter. You might have looked down at the bottom of the front page called summation notation. And you probably heard of the sigma. You know, maybe you have an older brother and sister that went away to college. Anybody visit a college campus and you see all the Greek letters all over the fraternity houses and sorority houses, and you're like, what are those? So you'll learn a lot of them as you go through your science classes, but this is the sigma way down here at the bottom of the page. And that's what we use to notate summation of a sequence. Listen, summation. Summation is sum, right? We're adding up the different values in the series. So yesterday you did the series. You figured out what's the series, what's the sequence, and today we're adding those terms together. So do you I can't talk anymore. Do you recognize the sequence I gave you?
Yeah.
It's from yesterday. It's called there you go. So that was what we did yesterday. Today, the series is just adding those terms together. That's all it is. So you've got 1 plus 1 plus 2 plus 3 plus 5 plus 8, and that equals?
2, 4, 7,
13,
12, 20.
We got there. All right, 20, yes. And so you're going to be doing a lot of adding today. So if you don't feel like your brain is on fire, you can use a calculator if you want. A lot of what we need to learn today is the notation. So when we see the notation on a test or quiz, Eric, we'll know what we're looking at, and we're not going to freak out and do the wrong thing. I don't know what's so interesting about your hand, but you should start paying attention to me. Sometimes, and this is going to happen in your homework, sometimes you're going to be asked for a partial sum. So sometimes we're going to add up the whole entire series, and sometimes we're going to get a partial sum. So you're going to see this capital S with the little n, the value for the number of terms that we're going to add together. So from the Fibonacci series, if we were doing Fibonacci, S1 would just be 1, because that's the first term in the sequence, and we just add the 1. If we were doing an S2, we would do 1 plus 1, so our answer would be 2. So you're just adding the first two terms. S3 would be 1 plus 1 plus 2, which gives us a 4. So S3 is a 4, so you get the idea. And S4 would be adding the first 4 terms, so it's 1 plus 1 plus 2 plus 3, so we get a 7. So you get the idea of the notation. True? We're okay with that? All right, so moving on down, this is mostly what you're going to see today is summation notation. Oh, why did it not go under there? All right, so you're going to notice that we have under the sigma where we start, right? We start with the first term, not always, but a lot of times we start with the first term, and it will be a value of 1, and then we end with a 5. And so notice it says k equals 1, and then it gives you right here, this is your explicit formula. So every time we do this, and we're going to do this one first, we're going to actually see what this equals. Summation notation means we're going to find all the terms, and then we're going to add them together. That's all it is. It's like one more step from yesterday. So for k equals 1, we're going to do 2 times 1, which equals
1. Oh, my bad.
Or 2. On Fridays, it's 2. For k equals 2,
4.
we're going to do 2 times 2, so we get a 4.
Fridays is 2.
You're welcome.
I'm still laughing at that.
So k equals 3.
6.
2 times 3 is 6. And so for k equals 4, 2 times 4 equals 8. We get the bilingual aspect. Thank you, Matthew. It's good practice. Like if you're taking Spanish or French, do
I
it.
failed out of Spanish.
Failed out of it.
Yep. I got 28%.
All right, now here's the thing. We started with 1. We went to 5. Leah, you with me? So once we get to 5, we're done. And then we're going to add this up. Go ahead, add it up. It adds nicely, doesn't it? Do you make the 10s? Anybody with me? You make the 10s?
Yeah, I made it to 10.
2 and 8 is another 10. 4 and 6 is another 10.
Yes. Don't forget to add everything.
What 10?
Thank you.
How's that 10?
So look, you have a 6
I was Spanish
grade. You have a 2, that's all.
Oh, I didn't do the 5th.
Oh, if you didn't do the 5th, you're going to be short a little bit. You're going to get a 20. So does anybody have any questions? All right, so everybody keeps asking me this. Do I have to show all of that work?
Yes, you do.
I would like you to at least show me the terms. Excuse me, let's listen. There's a lot of these that are simple. Some of them get a little bit more complicated. If they're complicated, I would show my work for sure. But this is a simple one. So if you wrote 2 plus 4 plus 6 plus 8 plus 10 equals 30, I'd be very happy with your answer. Okie dokie? Let's take a look at some others and see, because we're going to get all different kinds of explicit formulas to work with.
Wait, I got a question.
Let's raise your hand then,
My
Jonah.
hand is raised. I was still.
Oh, you just have to wait for me to call on you.
Oh, okay.
Yes, Jonah.
So the S 1 through 5, the S stands for sigma. So that weird E looking thing is the sigma.
Yes, Jonah.
Okay.
That's the Greek letter sigma.
It's the uppercase one.
Wait, that's on
Lowercase is like this.
All right. Let's get back together. Tyler B., I need you to come sit up here. You're driving me insane. You talk too much. Yes, sir.
Do all calculators have a sigma option?
I don't know. I don't even know if mine does.
Is that something you're going to
You can sit there. It's fine. All right. So this one, we start with 1 and we end with what number?
1.
With a 4. So we're going to plug in for K for 1 through 4. Now, guys, do you recognize this as linear? It's good if you can recognize it as a linear formula, because that way when you get your answers, you're going to see a pattern, and that can help you detect if you've made a mistake or not. And let's take a look at it. So when we start with K equals 1, we're doing 2 times 1 minus 1. So we get a 2 times 1 minus 1 gives us 1. Did you say O? That was you, Eric? Oh.
Was that O 0?
K equals 2 is 2 times 2 minus 1. So 4 minus 1 makes, for K equaling 3, we have 2 times 3 minus 1 equals 6 minus 1, or 5. And for K equaling 4, we have 2 times 4 minus 1, which is 8 minus 1, which is 7. Now, when you guys look at the terms in the series, do you notice that they're all in the same pattern? We're adding 2 both times. That's what linear looks like. It's because of slope, right? So you're going to have the same little addition or subtraction. That can help you recognize if you've made a mistake on one of them. Make sense? And so we add those together. Let's see, there's a 10 and a 16, right? So there we go.
So 16 would be our final.
16 is your final answer, but at least I would want you to show me the 1, 3, 5, and 7, okay? What's wrong?
Her hair looks like a That's how they do their hair.
Yes, sir.
How do we know to stop at just K?
Because it has the 4 on the top. That's where you stop. You start at the bottom where it goes 1 to 4. Okay? All right, let's take a look at number 2 because I gave you one that's kind of challenging. Before you start some of these things, Leah, let's get focused. You should think about the order of operation. This is exponential. So this doesn't really have the same type of pattern that you saw over here because it's exponential. But when you do this, you're going to first take care of this -1. Then you're going to do 2 raised to that power. And then the last thing you do is multiply by the -5. So make sure you use the proper order of operation. So we're starting at 1. And where do we end, Matthew? Cinco. It doesn't really matter what month it is, but yeah. So k is going to equal 1. So it's going to be -5 and 2 to what power? 1 minus 1 is... Ooh, now here's a good question, and you had this last night. What is 2 to the 0 power? It's 1. It's 1.
I agree.
You're amazing, Jonah. What is it, Jonah? Jonah, what is it?
1.
Oh, I thought you were going to ask me another question. Okay. All right, so take a few seconds to work on this one quietly on your own. I know you can do it. You just have 4 more to work on. If you're stuck, raise your hand. I'll come over. I'm happy. Oops, I skipped a number. Oh goodness, Mrs. McGuire. Where's my whiteout?
You have any graph for me?
That's okay. This is a 2 to the 3rd, right? Which is 9. Is 8.
9.
You know what's sad is I already did this lesson in block
You
5.
know Celsius? I got you.
I don't want a Celsius, thank you.
No, it's for my junior beat.
What's 2 to the 4th?
16.
16. And 16 times -5 is?
80.
So did you notice a pattern?
They're doubling.
They are doubling because it's a base of 2. That's why. Okay, let's add them up. There's 155. That we're recording that, Elizabeth.
Mr. Moore, I think that's a congrats.
Because I got it right.
Oh boy. All right, any questions on number 2? No. All right, go try number 3, please. 3. Shh, quietly on your own. Number 3.
So this will go to 6.
There you go. 1 to 6.
Mr. Ware? What is this? Mr. Ware? He likes the picture.
I thought you took his Bible.
Wait, what did you take? My whole bunch.
I took his Bible. I was trying to, if it was my Bible,
break the Bible?
I would be very upset.
All right. I
Bill
didn't
later.
mean to distract you that much. My goodness. I just want to get my whole puncher.
Okay. Second question.
All right, how are we doing? How are we doing on this? Did you add them all together?
Yes, Miss
All right, here's my terms. Check your terms with Mrs. McGuire's. Make sure you got the right terms. Pardon? Oh, no, I didn't add them yet. Yeah, so to keep in mind these are negative. So this is negative 16, right? And this is 20. I'm hurting my brain. That's 21. It's 47. So this is 47, these bottom three. Minus the 16 gives you the 31. Because I think some people forgot these were negative and you added them all together as positives. That's why you got that big number. Yeah. All right, how'd we do on that one? They're not that bad, are they?
No.
Okay. Number 4, it doesn't have a variable next to it. So what do we call it? Constant. Okay. Now this one starts at the 4th term and goes to the 10th term. So it's different. It's a little bit different. So you're starting with k equals 4. So what is k equal 4 actually going to be? 6, right? And k equals 5 is? They do all equal 6. You're right.
36. So it's satanic. Yeah.
I don't think so.
I can't believe it was the market.
I'm running into the out of paper here.
We don't let 10 do.
Oh, no, it's just one side.
All right, so boys and girls, instead of adding these all up, what's a faster way to do it, Ben? Multiplication is fast addition. So what would this be? Who can tell me what this would be, Jonah?
60.
What?
36.
6 times. There is 1, 2, 3, 4, 5, 6, 7 of them.
42.
Yes. All right. So one thing I want you to keep in mind, we're going from 4 to 10, but you're including the 4th term. So that's why it's 7 terms, right? There's 7 terms. All those 7 terms are the number 6. So that's why it's 6 times 7. This is actually a handy-dandy little formula that you can use. Because what if Mrs. McGuire did like 4 to 100? Would you want to sit there and go 6 plus 6 plus 6 plus 6? No. So if I did 4 to 100, that would be 97 times 4 times 6. Times 6. Okay. Now, we have 3 formulas down here at the bottom in this little formula section. And this is the one we're doing right now. The C is for the constant. And so I want you to realize that when it comes to constants in this formula, that you have to know the number of terms. This one goes from 1 to n. But if it doesn't start at 1, then you have to think about what would the number of terms be, just like we did in number 4. Are you with me on that? But you can use multiplication instead of adding them all up. So go ahead and try that on number 5. Go ahead and do... Oh, number 5 is different. It's not a constant, is it? My bad, we can't do that. All right, so we're going to go, number 5 is actually the linear one. So let's just take a look at number 5 if we didn't have a formula. If we did not have a formula, oh, well, hello. I'm recording too, so yay. Oh, wait.
You can pause it real quick. I kind of want to be.
Please, sorry. It's not appropriate. All right. Number 5. We're starting at 1, guys. So if k equals 1, what do we get?
1.
If k equals 1, we get a...
1.
15.
Eric, if k is 1, what do you get?
N times n plus 1.
N times n plus 1 over 2.
1. right?
Yeah, but one
Relax.
into the.
I'm going to do that next. I'm doing the formula next. I just want you to see what it looks like.
You get K, but K is 1.
So if K is 2, what do you get, Eric?
Oh,
2.
Thank you. So K is 3, you get a...
3.
Do you guys understand how the series is working?
Yes.
Okay, I wanted you to understand what the series was doing first. Now, we could sit here and add numbers 1 through 15, or we could do the formula. I vote for the formula, because we have a formula when you have a linear K series, all right? Now, this only works if it's just K. If it's K plus 1 or K times 2, it does not work, all right? So we can put this in. This is n times n plus 1 divided by 2. And what is my n value, Josh M? What is my n value? It's not K. What's the n value to this one? 15, says Sarah. She's right. It goes, it was who? Oh, I thought Sarah said it. Sorry. Thank you, Tiana. So 1 through 15 is 15 terms. So you're going to do 15, and 15 plus 1 makes 16 divided by 2. Hey guys, 2 goes into 16 8 times. So you can do 15 times 8
Wait, is this your shortcut?
is 120. Yes.
Instead of plugging in all the numbers?
Yes, it's just shortcut. It's a formula. It's
You can plug in all of them.
you could.
And then
Yes. So here's the thing. You could plug them all in and do them the long, old-fashioned way. I think the formula is really nice. Get to know the formulas. All right, go try that out. Shh. Are we all okay with this?
yes.
Go ahead and try number 6. And you don't have to do it either way, but you know your mean old math teacher will probably do like 1 to 9,047. So
Don't do that. Please don't do that.
36.
that is. We can hold
that one's done too. Wow. Thank you. We're doing a Rubik's mosaic of a little boy in elementary school, and we made his picture, and the kids are working on the Rubik's cubes. So it's 600 Rubik's cubes we have to work. I forget his name. He's super cute though. I think he's like in 2nd grade maybe. Lena. In geometry? I don't know. If you had Mr. Dashukian, sometimes he goes off track and does whatever he wants, so maybe.
That sounds like him. That sounds like him.
All right, how many of you guys got a 36 for number 6? Yes, sir.
So is this going to be one of those things? Let's just say we were to do this on a test, and we don't necessarily remember your formula. Can we just do 1
Yes,
plus 2 plus 1?
yes.
We're not doing it.
Yes. I would, if I were you, at least memorize this formula. That one's super easy to memorize. This one kind of just makes sense, right? Because you're instead of adding them all up, you're multiplying. This one, we're going to work it out and see what it looks like. It's not that bad, but I'm going to ask Mrs. Moeller if I need to make you memorize this or if I am allowed to give it to you. Don't ask. So this is for quadratic, guys. But Jonah, this is our most simplistic quadratic. It's just k squared. All right, so it can't be anything that's more complicated, just k squared. So let's go ahead on the next side. We're going to bring this formula with us and try this on the other side.
As much as I want to. it
I know,
appears-
we already spoke. Goodbye. I love you. Have a good weekend.
I thought you were gonna be like,
Oh,
Miss Rand said she hates me, so.
Why is it done? Wait, why? Oh, never mind. What? It's about college.
okay. We'll talk after. Here we go. Let's look at number 7. Holy cow. Number 7. We're going from 1 to 12 with k squared. Now, you could definitely do this by hand, right? But you're going to have 13 terms to add up, and they're going to get super big. So I would recommend the formula. Now, did you guys notice that the formula is close to the other one? You start with n, the n plus 1, and then you go 2n plus 1. So it's just a tad bit different. I'm going to write it over here so we have it. The formulas are nice to have. So our n value is going to be what, Rebecca? It's a 12. So we're going to do 12. 12 plus 1. 12 times 2. Plus 1. So we're going to multiply those three numbers and divide by 6. Actually, 6 goes into 12 how many times?
2.
2. And 2 times 13 is?
26.
So 26 times 25 is what we need to do.
3,900.
Is it?
No, it's approximately 650.
It's 3,000.
No, that's already, divided by the.
It's
Yeah.
650.
Oh,
Yeah,
simplified.
I'm just.
So it is.
I forgot.
I was like, that sounds kind of big.
I'm just.
Because I multiplied everything on
I
that
didn't do
person
the
and I
cross
divided by the
multiply.
six.
My
So
brain is just-
I know 25 times 25 is 625, so that makes sense. All right, go ahead and try number 8 on your own, please. Do number 8.
Okay.
What's wrong, Sophia? 385, yes.
Oh, yeah, wait.
Are we all okay with 385? We're happy with that number? All right. Go ahead and do number 9. Last one on the page. It should go quick. Shh, don't say it out loud. I'll get your question in just a second. All right, raise your hand if you have number 9 already. Raise your hand if you have number 9 already. Should be nice and quick, yeah. Tiana, you got it? Number 9? All right, Ryan, what did you get for number 9? What did it say louder? 240, yes, 240. There are how many terms there, Tyler A? 60. And we're using the constant 4, so it's 60 times 4 is 240. All right, Miss Mileto, what's your question? You're good? Okay. We have homework in the book. Next week, you can expect a quiz after we finish 6.3, like midweek sometime. Not an April Fool's joke. The homework's not April Fool's either. I didn't do any jokes or pranks today yet.
Dr. Shopper, do you have a
What the heck is that? Oh, a baby. A gold baby.
Did you have a class today? Do you have a
That's so cute. I need a baby.
No, bro, it's actually like.
All right.
Give you my child.
You
I
gave me.
got